So here we go. We got our calculators out, turned on, ready to go. Everybody brought one, right? I don't know what you've been graphing, but I would suggest that you just do a standard window for this problem. So remember how to get a standard window? We just go to window. Well, you don't even need to go to window. Just go to zoom 6, and that will square your screen for you, or not square it. It'll give you a standard window, -10 to 10. Then I want you to get rid of any equations that you might have in there already. I don't know if you still have any or not. So go to y equals and clear out those equations. Now we're going to put this one in. Your absolute value is located in your math menu. So right here, see where I'm pointing in the first column, the third one down, it says math. Press math. There are lots of things in math. Go over to number, across the top, go over to number, and you see how the very first thing is absolute value? So you press that, and then you type in 2x minus 3. Now on the old calculators, you need to close the parentheses. On the newer ones, you don't have to. But you're taking the absolute value of 2x minus 3. And then our second equation is going to be x squared, just x squared. And we're going to hit graph. Now, did you get a v? Of course you did, because that's what absolute value looks like. And you also got a parabola because that's what x squared looks like, right? So if you don't have a calculator, please look on your neighbor. We got to know what's going on here. Now, the way we did this, the way I did this, with two separate equations, I'm going to go to second calc and then intersect, because don't I want to know where my two pictures intersect? Now, let's see if I can produce this. I got a V that looks like this, and I got a U or a parabola that looks like this. Now, the way I have mine set up, this point up here is a little bit fuzzy. So if you want, you can go back to window and make Y max maybe 20. And then when you graph, it'll be more clear. You'll have a picture that looks more like this. So I took my graph up higher. That isn't necessary to find your answer, but sometimes it helps to have a clearer view. What?
If you change like your y max and your x max, yeah, how do you?
What?
How do you know?
Just go to window and type in a new number.
Oh.
All right, let's find this point. Remember how we do that? Second calc intersect. And I want to find that point, so I got to move my cursor. So on the absolute value graph, it's over here somewhere. And then on the parabola graph, it's down here somewhere, surrounding this point, in other words. And I got, oh gosh, did you get -3?
Yeah.
That's nice. And then I start over again.
When I did that, it says x equals -3, but y equals 9.
Y equals what? It doesn't really matter.
I just had it.
Yeah, I'm looking for the x values. I mean, that's nice, that y is 9, but I'm really looking for the x values, right? I'm solving. Okay, so second calc intersect, starting over again. But now I'm going to surround this point. So move your cursor on each curve, so it's on either side. And that one came out to be x equals 1.
Yeah.
So those are the solutions to that equation. Now, I took these problems out of a book somewhere. They're rigged, obviously. I'm gonna make my own problems up and your answers aren't gonna work out to be this neat, but it doesn't matter, right? The calculator's gonna tell you what they are.
So we should,
So if it comes out 1.7392, okay, that's what it comes out.
so we should expect weird answers.
Yeah, cause I'm making them up. So unless I'm incredibly lucky,
Normally
which I
when
am
I
not,
Normally when I get weird answers, I'm like,
yep,
oh, must
we're
have
gonna
done
get
something.
weird answers. Yep, don't worry about that. All right, next, let's repeat the process. Now we are doing this one. Okay, so I'm gonna go back to y equals, I'm gonna clear these other ones out. And I'm going to type in the square root of x plus 7 and negative, and remember when you do negative, you gotta use your negative button, don't use the minus. Negative x squared plus 5, graph. Your picture is absolutely fine as long as you can see the points of intersection. Can you see them? If you want to adjust your window, I didn't make any changes. I left mine the way it was in the last problem. That I can see everything I need to see. Do you see something that looks like this? This is your square root curve, and this is your negative x squared curve. All right, find those points of intersection. Second calc intersect.
Got like -1.64.
I got x equals negative 1.64. If I round to the nearest hundredth, you'll have instructions on how to round. And then the other one, second calc intersect. I got 1.45. With me?
Yeah.
I have a question really quick. My calculator has this like very random line showing up in the same place. It's like a second, like above the x.
Go to y equals.
Okay.
Make sure that you don't have anything put in except your one equation. Scroll all the way down. Find it? Get rid of it. All right.
Oh, you graduation, bro?
Not the highlight of our day. Number 8. Solve with the quadratic formula. Kids, I've only given you one example here because it is completely expected that you know the quadratic formula. What's the quadratic formula? No y in it.
Oh, sorry.
X
X equals
equals
negative b.
negative b plus or
The
minus.
square root of b squared minus 4ac.
Over 2a.
2a.
There we go. And by the A, B, and C, what are we talking about?
Coefficient.
A is right here. B is right here, including the negative. And C is right here, also including the negative. So we plug it in. Mr. Fahey, what's happening back there? Okay. Need you paying attention. X equals negative b, so that'll be 2 plus or minus the square root of b squared minus 4 times a times c. Watch all those negatives in there, all over 2a. So cleaning it up, what do we have underneath that radical?
88.
We have, what'd you say?
88.
Total 88? Cause this is 84 plus 4, 88, perfect. Now, don't you dare cancel 2 into 6. In a 3-part problem like this, if you can't cancel out of every part, you don't cancel at all. And you never cancel under the radical. It's gotta be outside stuff that's getting canceled. So, as it's written, nothing's gonna cancel, but what do we notice?
You can simplify the square root.
88 can actually break down. So it may give us some hope. 2 plus or minus, okay, what's 88?
2 square roots of 11.
2 square root 22.
2
Oh
root
my
22?
God, that's so bad.
2 root 22?
Yes, 2.
Now, do you see? I have a 2 and a 2 and a 6. Remember,
Yes.
under the radical is untouchable, so I don't care what's over there, it's irrelevant. It's just the outside numbers. I can take a 2 out of everything. 1 plus or minus square root of 22 over 3. There's our answer. This one is necessary. This one is not necessary. See the difference? Okay.
Why can't you take the 2 out before you break down 88? Because, like I know you said in a 3-part,
You can't. I mean, think about if you had 2 plus 4 over 2.
okay.
If you just canceled these two, you'd have 1 plus 4 or 5, and we know that's not the answer.
Yeah.
The answer is 6 over 2, which is 3. So the 2 has to come out of everything. Always.
Okay.
You have to cancel out of everything. If you're gonna cancel, you have to be able to factor. So you can factor a 2 out, you can cancel them. If you can't factor, you can't cancel. That's the easiest way to remember it. No factoring, no canceling. So I can take a 2 out of my numerator, so I can cancel out a 2. All right, last problem. Little word problem that involves the height of a ladder. So an 18-foot ladder, oh, what am I using? 18-foot ladder is leaning up against a building. Does it make sense to you that that's where the 18 goes? That's the
Yeah.
ladder. The distance from the ground to the top of the ladder, so this distance right here, is 5 more than the distance from the building to the base of the ladder. So if I call this x, this would be x plus 5.
Yeah.
And this building, we're assuming, and we're allowed to make that assumption, is standing straight up and down. So that's a right angle, which means that's a
Right
right triangle, which means that we can use the Pythagorean Theorem. So x squared plus x plus 5 squared equals 18 squared, the Pythagorean Theorem. So x squared plus, please don't square these individually, this is a FOIL, right? That's a FOIL. X squared plus 10x plus 25 equals, 324? Is that right?
Yeah.
Okay, thank you. What kind of an equation do we have here?
Quadratic.
Please do quadratic. And when you have a quadratic, we can always use the quadratic formula, right? If push comes to shove, but it's gotta be set equal to 0. So let's clean it up. 2x squared plus 10x minus 299. That might factor. I could divide everything by 2 and complete the square, but I think I'll just use the formula. So negative b plus or minus the square root of b squared minus 4ac all over 2a. The formula is always my go-to if I can't or don't want to mess around with it. with me?
Yep.
Okay, let's talk about this for a second, just from an efficiency standpoint. This answer is gonna be extraneous. I'm not even gonna waste time typing it in, because what's gonna happen when I do -10 minus something and divide by 2, I'm gonna get a negative number. And in my problem, can x be a negative number? No. So whatever that is, it's called an extraneous root. You've heard of that word before? An extraneous root is a root that just happens. You didn't make any mistakes, but it doesn't work. It just doesn't fit the problem. So what's this one? Let's see. -10 plus the square root of 2492 equals, divided by 4. Did you get 9.98?
Yeah.
And was that feet, I think? Yeah. Be very careful. How far up the building does the ladder reach? I haven't answered the question. This is how far up the building the ladder reaches. So the answer is actually 14.98 feet.
Mm-hmm.
Is that all right with everybody? All right, let's do a quick review here. And P5 will be due on Wednesday, so make sure you're keeping track of that. And here's a quick little practice.
I did.
All right, did everybody get one? All right, here we go. Listen, if we're not gonna pay attention, we're not gonna review. This is for you. Okay, here we go. Number 1, name the property shown. All right, so let's look through those and see what we think. For problem A, what do you think? Number 1A, what property is that?
Reflexive.
It's not reflexive. Reflexive has exactly the same thing in exactly the same spot on both sides. What is it? Wait, I'm looking at Austin.
Symmetric.
It is the symmetric property of equality. So you need to write symmetric property of equality. That would be the best thing to write. But if you just put symmetric equality or symmetric equals, that's enough. It's the symmetric property of equality. Okay? What about B? What's B? Associative. Associative of multiplication. Why is B not commutative? What has to happen if it's commutative? Well, grouping is associative. If it's going to be commutative, the order has to change. And the order in this problem did not change. It's 7xy, 7xy. So this is associative of multiplication. You need to have both of those, associative multiplication. All right, what about C? That one is commutative. That one is commutative for multiplication, yes indeed. Yeah. Yeah. How about D?
Additive identity.
Nope, not additive identity, it's the additive inverse. When things cancel each other out, it's an inverse. Okay, that's an inverse, that's additive inverse. 8 and -8 cancel out, additive inverse. What about E? Multiplicative inverse. Now, you do not need to write that whole word, but you need to have inverse and multiply somehow in that. So mult inverse, right? They're canceling. Okay, wait, that looks familiar. Oh, yeah, it looked, at first I thought it looked like the same, but it's not. Those two sides are exactly the same, aren't they?
Yes.
That's reflexive of equality. Reflexive of equality. How about G?
Transitive.
Transitive of equality. If x equals 7z and 7z equals 8, then x equals 8. That's transitive of equality. NH?
Distributive.
That's the distributive property. Now, somebody mentioned, and I don't see it on the paper here, but it's one of our properties that we need to know. Somebody said for one of them, additive identity. Now, this is the additive inverse because those two things cancel each other out. Additive identity would look like this. Because when you add 0, you get the identical thing back again. So adding 0 or multiplying by 1 is an identity. Those are the identity properties. Adding 0, timesing by 1 changes nothing. Okay? In Schoology, I'm pretty sure I put the extra property practice worksheet and answers. If I didn't, check sometime, send me an email and I'll get that in there, okay? All right, if you want to practice some more. All right, we got more to do there. Number 2, simplify. All right, so what's your strategy here? Lots of possibilities. So there isn't just one way to do it. There's lots of options. What is your thought when you look at this problem? Corinne?
I'm just thinking that I can give it a try. First I would flip the negative.
This one?
No, I would.
There's lots to do, and the order you do it really doesn't matter. I think, yep,
I would times everything by the -2.
okay, so he says he's gonna raise everything to the -2nd, which is fine. Let me share with you what I would do first, because I think it's easiest. I like to clean up my parentheses first.
Okay.
So instead of keeping all these double letters, I'm gonna go ahead and combine them. So I'm not gonna change a thing, except I'm gonna bring these x's down. So I'm gonna have 8 of them on the bottom. And I'm gonna cancel these so that I have 5 on the bottom.
So doesn't it?
Now I have less to worry about. You do not have to do that first. You have to do that at some point, but you don't have to do it first. I like to do it first. Okay?
Is the rule of thumb like always when you have negative and positive exponents like in a fraction like this that it could be like -3 minus 5, you put whatever number that is where the larger value was, like top or bottom?
No. These 3 are gonna come down, right?
Right.
So I have 5 down there already, and I'm bringing down 3 more. So I have 8.
Yeah.
Or you can subtract exponents. -3 minus 5 is -8. So it means 8 on the bottom. All right, now I think I'm gonna go ahead and flip the whole shebang. Because isn't that what a negative exponent on it does?
Yep.
Now you might do this in a different order, but let's see if we come up with the same answer. Now, I'm gonna take everything to the second power, including the 4 and the 9. So 16, x to the 16th, y to the 10th, over 81. That should be what you all came up with, no matter what order you did it in. Did anybody get that?
Oh, yes.
Now, if you just copied mine, obviously that's what you got. Who did
Oh,
it
no,
on
I
their
got
own?
it.
I mean, I put the numbers like from my head. I don't know.
Whatever you want. All right, we got one more. Let's look at this exponent. Okay, these are separate parentheses with separate exponents. So we'll just go ahead and do each one. So 27 x cubed y to the 12th, that okay with everybody? And then that's still multiplied. Okay, what is 2/3 squared?
4/9.
4/9. And then x to the -4th, y squared?
Yeah.
The whole thing is times. So you can regroup, do things in a little bit different order. So 27 times 4/9 would be what?
12.
Yep. 12. X cubed times x to the -4th would be x to the -1st, which is going to be 1/x. And then y to the 12th, y squared will be y14. So there is our final answer. Again, you might have done those things in a little bit different order, but this is the answer you ultimately need to come up with. All right, number 3. Given a circle with a diameter -1, 4, 3, 10. Keep in mind, the relative position of those points is irrelevant. I need to write the equation of this circle. What does it take to write the equation of a circle? It takes the center and the radius. That's what you gotta have. Gotta have the center and the radius. So how are we gonna find the center out of this? Midpoint. Midpoint is average. -1 plus 3 divided by 2. 1. 4 plus 10 divided by 2. Center's at 1/7. X minus 1 squared plus y minus 7 squared. That's the beginning of my circle equation. Now what do I need? I need the radius. So could I find the distance from here to here? Would that be a radius? Okay, so that will be the square root of 1 minus 3 squared
That's the start.
plus 7 minus 10 squared. One minus 3 is 2 squared is 4. I know it's negative, but it doesn't matter because I'm squaring. 7 minus 10 squared is 9. So my radius is the square root of 13. When I write my equation, it's the x squared and the y squared and the r squared. This is r squared. So what would r squared be?
13.
So your equation equals 13. Solve by completing the square. Could we solve this using the quadratic formula?
Yeah.
Yep, but that's not what the directions say. It says solve by completing the square. So, how do we get started? Got some work to do to get started. What do we need to do? Move the 3 over. Can't complete the square with a 3 there. I need another number in there, not a 3. What else? Tess? Gotta divide by 2. Cannot complete the square. Cannot complete the square with a coefficient out in front, because this parentheses must be x plus something squared. Gotta have a plain x sitting right there. All right, here's one of my made-up problems, right? This isn't gonna be beautiful. Half of 5 halves, squared is 25 over 4. So in my perfect square here is gonna be x plus what? 5 halves, beautiful. Then I'll get a common denominator over here. Is it 31 over 4?
Yeah.
Okay, it's all right. Now what? Square root it. So x plus 5 halves equals plus or minus always root 31 over 2. Because when I take the square root of a fraction, it's square root of top over square root of bottom. And then I'm gonna solve. So x equals negative 5 halves plus or minus the square root of 31 over 2, which if you want, you can go ahead and write this way. You don't have to, I don't care, it doesn't make any difference. If we did the quadratic formula, this is the way it would come out. Right?
If we use decimals, I got a different answer, but I think it's the same.
Now, I'm sure it's the same, but we're not using decimals because we want to simplify our radicals as much as possible, so I don't want to see a square root of a radical.
So you can't.
Or square root of a decimal. Nope, we don't need a decimal. Let's be friends with fractions. If you're doing it on your calculator, then it doesn't matter one bit to me, but if we're doing it by hand, this is no calculator. It's easier with fractions. All right, what's next? Find y if the slope is negative 7/5. So I've got some line out there, and I know the slope is negative 7/5, and I know the line goes through these 2 points. Well, this one's not too hard. What do we do? Set up our slope formula. So we can actually do point slope if you wanted. I think that's a little extra work. I think I'll just set up the slope formula. So slope will be y minus 7 over 3 minus negative 8. And that has to equal negative 7/5. So y minus 7 over 11 equals negative 7/5. How do I solve something like that? So 5y minus 35 equals negative 77. That was a very good year, by the way, not negative, but that's the year I graduated from high school, 1977, oh my gosh. So 5y equals what? Negative 42. Did I subtract or add right? So I got negative 42/5. All right, 2 more, and they're kind of the same. Write the slope-intercept form of a line that is parallel to this one. And contains this. And then we're going to do the same thing. This is the parallel one, then we're going to do a perpendicular one. So what do we do first?
Bring the X over.
Yeah, we gotta solve for y. Now, if you don't wanna mess with all those negatives, cause you're gonna have some negatives, you can actually add the y over here and bring the x over.
That was -7.
Oh, did I? Oh, it is. Oh, I gotta divide. Thank you for pointing that out. So I got a slope of 3/7. Did you? If I'm doing parallel, then I'm going to use that slope. So y minus 1 equals 3/7 x plus 1. It stipulates I need slope intercept, so I gotta go ahead and work this out. So I'm getting 3/7 x plus 10/7. For my parallel line. Now, what will my perpendicular line look like? Same exact thing, except instead of using 3/7, I'll use -7/3, and everything else is exactly the same. So I'm getting -7/3 x minus 4/3. Now, there are a bunch of problems on there. Quiz won't have all of those. Your quiz might have problems 1, 3, 4, and 7, or something like that. There'll be different versions of the quiz. There'll be something like this.
Can we get our calculator?
Nope, don't need it. Did I use it one bit on this? Nope, you don't need it. You don't need it. You're smarter than me. You don't need it. All right. That's the quiz Wednesday. All right, here we go. Oh, by the way, if you're extended time, please don't sign up for extended time quizzes, all right? You miss too much class, good things happen, you miss, so you'll have time, don't worry. Never been a problem, been doing this for 42 years. You can do quizzes with us. Tests you'll take over there, okay? All right, P6, here we go. Equal complex numbers. Chris thought I was done. No. Lots of math to do. Well, then you work it out. Go to the side. All right? These guys are whining and complaining because anything above 13 squared, I don't know. Okay, so work it out. 13 times 13. You can figure that out. Okay, the quiz is like a practice we just did. We just got done saying, Mr. Fahey, I hope you're paying attention, that I'm going to pick and choose a few problems off this when I write these quizzes, okay? All right, now we got P6 and P7 to go, and then we will take a test. So it's coming up soon. Equal complex numbers, conjugate powers of I. Those are vocabulary type things that we have to talk about. So first of all, let's refresh our memories. A complex number is of the form A plus BI, where A and B are real, and I is the imaginary unit, right? That's what a complex number is. Every number that you know of right now, probably, is complex. So the number 5, 5 plus 0i. Root 13 plus 0i. Every number you know of is complex. If two complex numbers are equal, that would be like saying A plus BI equals C plus BI. Can you make any conclusions about that? If these two numbers are equal, then what has to be the case? Maureen?
A equals C.
And?
Oh, GI equals.
Well, B equals C. Yep, that's exactly right. If two complex numbers are going to be equal, then their real parts have to be equal, and their imaginary parts have to be equal. It's that obvious. So when you're given a problem like this, x plus yi equals 7 minus 6i, you will know that x has to be 7 and y has to be
Negative
6. It's easy. Easy. Okay? Lucy, you still with us?
Yeah.
Okay. I'm gonna sit up. Get kind of comfortable back there. Okay. Conjugate. The conjugate, so I'm gonna use notation like your book does. If complex number z, that's just his name, they call it z throughout the book. Complex number z is a plus bi. Then the conjugate of z, which is noted with a bar over the top, that's called the conjugate of z, is a minus bi. So you probably knew that already. The conjugate of 7 minus 6i would be 7 plus 6i. So when you write a conjugate, the middle sign changes, the I part changes.
By the complex numbers before the real, is that an E?
It's is an element of, that's a symbol from geometry, is an element of. So it belongs to the set of real numbers. And then powers of I. So any complex number you can write the conjugate for just by changing that sign. Now, the powers of I. Sometimes when we do problems, we run into situations that have i's to bigger powers than 1. So for example, if it's just 7i, it's just 7i. But what if it's 7i squared? Or 7i cubed? Or 7i to the 4th? Or 7i to the 5th? And so on and so on and so on. Those need to be simplified. Any power of I bigger than 1 is going to simplify. So this one does, and I'm done with that. Anybody know what I squared is?
Negative 1.
Dom? Well, it's negative, I squared is negative 1. So in my example with 7i squared, that would be 7 times negative 1 or negative 7. So when you see an I squared anywhere, you're immediately going to change it to a negative 1. We're not going to mess with powers of I. We're going to simplify it. All right, well, what about I cubed? Negative I, because isn't I cubed the same as I squared times an I? So I cubed is going to be negative I. So in my example, it would be negative 7i. We're never leaving an I cubed. We're changing it to negative I. All right, what about I to the 4th? 1. Because isn't I to the 4th I squared times I squared? So negative 1 times negative 1 is 1. So I to the 4th will always be reduced to 1. So this is just 7 times 1 or 7. How about I to the 5th? Yeah, the beauty of this is it's cyclical. Now that we have a 1 involved, any power bigger than that can be broken down into I to the 4ths and then extras, but every I to the 4th is just 1, so we can kind of ignore it. So 4 of these i's get ignored, and then I just have 1 left over. Well, what if we have a math book problem, because this never happens in real life that I know of, but it's an interesting math book problem. What if we have I to the 762? If we divide that exponent by 4 without a calculator, that means, no, it's not negative I, This
Negative
would
one?
be-
Negative 1.
This would be negative 1. This means that if I wrote out 762 I's in a big long row and circled every group of 4, because that makes 1, I'd have 190 ones. 190, so it would be 1 times 1 times 1 times 1 times 1, 190 times. And then at the end of all those circles, there would be these 2 little leftover I's. And I times I is negative 1. Perfect. All right. Let's do 1 or 2 little problems here, and then we'll be done for today. All right, so A says let's add 2 plus 3i and 3 minus 5i. Problem A says take your Z1 number and add your Z2 number. Well, how easy is that? Collect like terms, right? So we end up with 5 minus 2i. Now we're gonna subtract our Z sub 1 minus 2 times our Z sub 2. Well, again, this is really easy. Go ahead and distribute over here. So minus 6 plus 10i. So it looks like our answer is negative 4 plus 13i. Okay, one more and then I'll stop. Okay, so now we're gonna do 3 Z sub 1s times Z sub 2. So 3 Z sub 1s times Z sub 2. I heard somebody say FOIL.
It was me.
Now, you were right, we're gonna FOIL. Now, here's the deal though. You can either distribute the 3 and then FOIL, or you can go ahead and FOIL and then distribute the 3. Multiplication is commutative, so the order you do it, it's associative, the way you group it doesn't matter. So, what do you want to do first, FOIL or distribute? Distribute, so that would be 6 plus 9i times 3 minus 5i. Again, it doesn't matter, so if you'd rather FOIL first, that's fine. 18 minus 30i plus 27i minus 45i squared.
18 minus 3i plus 45.
This becomes plus 45 because I squared is negative 1. 45 adds to 18 and makes 63. And those two add together minus 3i. Is that okay with everybody? Okay, a lot of ground covered, a lot of ground yet to cover. We'll keep rolling through.